Hello, welcome to our next tutorial of QUICKSURFACE. In this step-by-step tutorial we will learn how to create reverse engineering of this prismatic part. So let's begin. I'll just go select File, New, and we'll start from scratch. In order to begin, all you need to do is just go to the Help, Example Files, and load the bearing housing. This is the simple mechanical part that we want to do a reverse engineering. I would assume that you already have watched all of our tutorials, so I will not go in details too much about how to navigate, and I assume that you have some basic knowledge about QUICKSURFACE. What I want to do as a first step is just to make sure that the object is aligned. For this reason I need to extract the planes at the bottom, on the side and the other side to be able to align the object. I will select Extract Primitives from the toolbar and will go and use my magic wand. We'll click somewhere here. Make sure that the value is 3 degrees for the purposes of this training, and you can pick some extra areas so you can get this plane correctly. Click on the plane icon. If you want to explore if you created your plane correctly, you can just click on the analysis and you will see the deviation. If you are happy with this, just press create and stay. Now I will carry on and try to extract the rest of my primitives, which is this side, clicking here in the middle, and we'll pick the icon for the plane. Again, we'll press the create and stay. The next step is to extract this side plane, clicking somewhere here. It doesn't select everything, so I can just simply click on the rest. What I'm trying to do is just to get more information to be able to define my plane correctly. Clicking on the icon will create my plane. You can see that the plane is imperfect. And the reason for this is because it automatically constrains this to be perpendicular to my bottom plane, while at the same time tries to create the best fit through the points. I'm happy with this and I will create and stay. I have the 3 planes, which are enough for me to define the coordinate system, and we'll close this mode for now. The next step would be to use our alignment tool, which is accessible from the toolbar, selecting the Align button and choosing Align by Coordinate System. We need to pick 3 primitives to be able to define our coordinate system, and the first one is this plane. Click on it. You see that the Z direction is flipped, so I'm choosing the flip direction of the Z orientation. The next step would be to pick this plane, which will be my second plane, and this will define where they intersect, will define my axis. By default it decided that this is the x-axis, which is what I want, but I want this to be flipped. And the last step I need to do is just pick the third plane, and you will see that it says that it's fully defined. Now, because we have these 3 primitives, this is enough for us to define the coordinate system. When I'm happy with this, I just press apply and close the dialog. What we just did was that we aligned our object correctly into the space. In order to prove our results, I'm going to select display the coordinate system here, so you can see where is the origin. It's just exactly where it needs to be. Let me just hide these planes. So the origin is here, and we are ready to start our reverse engineering. The next step after we aligned our object is to start creating our bodies. We first need to analyze the shape to be able to understand what we need to do. And what I'm going to do is create this main body, then I will cut this hole from it, and we'll add this shape, and at the last step we'll create these holes through the whole body. So let's begin. I'm going to select the 2D sketch, which by default is on a XY plane, which is good enough for me. Holding the left mouse button over the plane will allow me just to move it and select the good representations of my shape. I just put it somewhere here in the middle. Then I can just create. What we see on the screen is the extraction of the points from the scan data that will help us to define correctly the main shape. Let me just go and turn off the coordinate system so I can see better the points on the screen. I'm going to use our brush tool. Make sure that the instant fit is turned on. Turn off the auto fillet. You can adjust your brush size in the way that it's quite convenient for your screen resolution, because by default it's really small. It looks like this. It's very hard to pick and to brush over, so I just put it somewhere here that it's convenient for me. I select the fit line because I need to extract the lines only. The way we extract is just by holding the left mouse button and brush over the points, like what I'm doing on the screen. As you can see, the software automatically creates a best fit line from my selected points, and because of this option, which is set to 1 degree, it automatically creates it as a horizontal line. This is very important when you want to do correct reverse engineering. Let's carry on and extract the rest of our lines here. Brush over here, zoom in with the mouse wheel, zoom out, and brush the lines that we need. At the moment I extracted everything that I need to create the outer shape of my body. I just press go back, and now the next step would be just to connect everything that we have extracted. We can do this with a command which is called corner trim. The corner trim command allows you to intersect all these points, and by extracting the primitives until they intersect. How we do this is just by holding the left mouse button and brush over the 2 points of our interest. Then the software will automatically extend the primitives and will intersect them. Let's try to intersect them quickly. As you can see, it's quite easy to build our shape, and we have our outer profile. I'm ready with this sketch. I will press OK. Let's turn on the mesh so we can see what's going on. The next step that I need to do is just create an extrusion. I just click on the sketch and select the icon which is for the extrude command. By default, it creates this extruded shape that you have 2 handles that you can move on the screen. I can pick the bottom one and move it somewhere here. Now, what we need to do is just to make sure that we do accurate extrusion, and I'm going to select my option which is called snapping. How the snapping works is if I just move my handle using the left mouse button, I can just move over on top of the mesh and it will pick a point from the mesh. As you can see with our instant analyzer, it automatically will display the deviation. Let's do the same on the other side of the extrusion. I pick this handle and start moving it on top, and you see it instantly snaps to the point that I pick. I can just pick here point, but everything becomes red. Why? Because this is an outlier. So I need to find the best place to position my extrusion. Once I'm happy, I just press OK. I created my main body and we'll continue rebuilding our shape here. What I want to do is just recreate this part. I can just click on this plane. of the existing cut body, and this will allow me to create a 2D sketch directly from my cut face. Then I can just start holding my left mouse button and start dragging my intersection plane, like what I'm doing on the screen, until I get a nice and good cross section from this shape. You can see that due to some inaccuracies or other reasons, we don't have a perfect shape, but this doesn't stop us to create a good model of what we have. I can just press create for now. The software automatically will start the edit sketch mode, and we need to recreate our shape. I'll just zoom in to see what I need to do here. At the moment I will ignore the holes because we'll do them last, and we'll try to repeat the same approach as in our previous sketch. Let's go to select points to fit lines. Now, instead of fitting lines, I will choose something which is called fit rectangle. I need to brush the 4 sides of the rectangle. What I'm going to do is holding the left mouse button and just brush over the lines that will define my rectangle, something like this. You see that the software automatically created this shape for me. Then I can go back and I have my sketch. Now the problem is that this line here is not perfectly aligned to the underlying one, so I'm just dragging it out of my shape. Let's create a line by selecting the line option here. I will create it from this point to this one. We'll hide the extruded surface, and the next step that I want to do is just get rid of all these lines here that I don't need. For this purpose I will use our trim command, which is located into the modify section. How the modifier works is you just hold your left mouse button and you start painting, and if it touches something it just removes it. The reason I did this is that this line that we extracted from the underlying shape is perfectly aligned, and this will allow us to create a proper solid. Let's go back and see our scan data. We'll select my sketch and create extrusion. In the same way, using the snapping tool, I will just move until I find a good location. For the bottom plane, all I need to do is just move it all the way in somewhere inside the body, so we can make a proper Boolean operation. So this is our result for now. I will just go and show my main body. And the next step that I need to do is to combine these two bodies into one solid. How we can do this? I hold the left mouse button and drag until I select both of them. Now we have an option here automatically which allows you to combine the two selected bodies. Or if you don't see this, you can always go to this button, click on the arrow, and you can see the combine selected solids. Or you can go to the cut menu and select the combine solids. The software automatically will create only one solid that is useful for you. Let's now create the two holes here to finish off our project. What I'm going to do is I will just click here and say I'm going to create a 2D sketch. For the purposes of demonstration, I will just place it in this view. What you can do, instead of dragging, I can use the outline mesh. The outline mesh will see and get the boundaries of the mesh, which might be in some cases better representations of your needs, and I will just use this approach. Now I'm happy and I will create my 2D sketch. I got my holes. What I'm going to do now is go into the create section, and I will select the fit circle command. In the same way, I just brush over the points that are of my interest, and this will fit circles for me. Then I'll go back and press OK. I have my sketch now. What I need to do is just click on the sketch, create extrusion. In this case, I don't need the snapping anymore, and I freely will move my extruded shape all the way through the body. What we can do in this case is to select different options how we want to create the extruded. Instead of later using a Boolean operation, we can use it immediately when we create the extruded shape. And I'm going to use now that I want this to cut from the existing bodies. Press OK. As you can see, we created this shape. In order to finish our project, I will just click on the mesh to see it on the screen, and we'll hide my latest result. I need to create something that creates an opening here. For this reason, I need an axis to define my shape, which is a little bit more complex. Let's try to do this. I'm going to construct my primitives. Instead of constructing them, actually, we need to extract from the scan data. Let's pick this, and this will be our cylinder that will define our axis for our shape that we are going to recreate. I will just spray to create a cylinder here. What I need to do here is actually make sure that the auto constraint is turned on and that it is parallel to the z-axis. What I mean parallel to the z-axis is because, let's turn on the coordinate system, the z-axis here. The software automatically will make a best fit of the scan data, but will make sure that the cylinder is correctly oriented and it's exactly tied to the direction of the z-axis. That will make sure that we have a correct orientation of our cylinder. I will just press create. The reason I created this cylinder is so I can use it. I can just click here to pick the cylinder. So I can use it to create my revolved surface. I'm going to create a 2D sketch by pre-selecting the cylinder. If a cylinder is pre-selected, the software automatically determines that this probably is created intentionally to have a sketch that is for revolved surface. What it means that you can now pick the profile that will define your revolved surface. As you see, we have different options when we create the cross sections, whether this is for revolved surface or for extruded, which means that if I drag the cross section, it will actually rotate around the axis of my cylinder. I will just pick a profile here, which is somewhere at 300 degrees, and now I can just press create. I created my profile. I will just hide my cylinder because I don't need. What I need is to create this profile so I can cut from my existing body. Going back, I'm going to select my shape. I'm going to feed a line, and we'll start extracting here. As you can see, the software automatically aligns this vertically or horizontally, but in this case we see that this is not exactly as it's needed, so it's a really personal choice how you want to do it. You can leave it as it is, or you can just click on it and select it horizontal and adjust manually by dragging to the right location to get the perfect result. This is what we understand as a design intent. Let's complete this shape. I'm going to use the corner trim and we'll start brushing on the corners that are near so they can intersect. At this moment, if you want, you can just brush again with the auto fillet command, and if you brush, it automatically will determine the radius of the fillet from the underlying scan data and will offer this for you. So this is what I'm doing. It's the same approach. You hold your left mouse button, you brush over the corner, and it makes the fillet for you. If you are happy, I just press OK. We need to do a little bit more here. I need to extend this out of my shape. What I'm doing here is just I'm getting off my original location, but the good thing is you have this guideline that allows you to avoid mistakes. So if I move, I can just always snap to this line. The last thing that I need to do is just to close this profile. The goal for me is to create a solid, so I can use this solid to cut material from my original shape. How can I do this? I just create a line by clicking on this point, and then I can put it somewhere here. The same way I can do at the bottom. Now I'm going to select modify and try to modify this line. What I'm doing now is trying to put the lines all the way to the intersection with the vertical axis, which will be used for the revolved surface, because I want to create a solid here. Once I have this shape, I'm ready to go, and I will press OK. This is my sketch. The next step that I need to do is to create a revolved surface. How to create a revolved surface? There are several ways. I can just right click on the sketch and select revolve. I can just click on the sketch and it will offer me an icon on the screen to create revolve, or I can go to the construct menu and select revolved surface. Either way, they just do the same thing that you need. I'm happy with this. I can just press OK. You can see that I see the sketch on the screen. I can just go and hide it from my feature tree. Let's go back and get our original shape, which is this one. The last thing to complete our project is to remove material, and what I'm going to do is just click on this shape, select cut from selected solid, and then I will pick the last created shape that we built. Now you can press OK. As you can see, this is the result of our shape. I just hide the coordinate system and will show the mesh so you can get idea what we did in this tutorial. I hope this is useful. Thank you for watching.